Okay, so let's just check in on solving the equation. What do you want to do to solve that? Think up next. It's cubic, right? It's degree 3, but there is a common factor of x everywhere. If I take that out, we get x squared minus 5x minus 6. So we've got one linear factor that tells me that one of the intercepts or one of the solutions is 0. And then we've got one quadratic factor that, well, since it's a quadratic, we know how to solve. So how do you want to do that? Okay, fine with me. X equals 0 from this one, right? And on the other hand, x squared minus 5x minus 6 equals 0. So negative b squared minus 4 times 1 times negative 6, so plus 24, excuse me, all over 2. So 5 plus or minus 7. So 12 over 2, negative 2 over 2, or 6 and negative 1. So 1, 2, 3. 3 solutions to the equation, 3 x-intercepts for the function, right? Those mean the same thing because we set it equal to 0. Now, we got to figure out the inequality then. What we just learned is that negative 1 and 0 and 6 are the places where the answer to the inequality can change, right? It can go from being true to false or vice versa. So what that means is, since we got 3 intercepts, there are 4 intervals that we need to check, right? The stuff around and between those 3 intercepts. So I need to check here, 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 and here, those 4 intervals, to figure out if this inequality is true or false on each of those. You can do that by testing points if you want to do it like numerically, right? Plugging in, you can do that. That's fine. So I would need to pick something here like negative 2. You got to choose something between negative 1 and 0. There is stuff between negative 1 and 0, right? Just not integers. So negative a half, for example, would work. Something here and something here. So I would need to plug in and test those 4 points and see if the inequality is true or false. Or we can use what we know about polynomial functions and graphing to do the testing part graphically, right? So what kind of function is this? Cube, right? Degree is 3. The leading term is x cubed. So what do the ends look like? That. They go in opposite directions and it winds up pointing up. We didn't factor it along the way to solving, but we have the information that we need to factor it now. How many zeros did we get? 3, and the degree was 3. And if the degree is 3 and you got 3 zeros, that means they each must be multiplicity 1, right? So none of them are repeated. None of them are going to bounce off or anything. They're all just going to go straight across. So if I know what the ends look like and I know where the zeros are, I can draw this in just like that. I don't know how tall it is, but I don't care either. I know that it crosses the x-axis at those 3 points and the ends end up going like that. And if they're all multiplicity 1, that means they just go straight through, right? So it's just a nice smooth, up and down, and then up again kind of curve like this. So if we want to know where it's less than or equal to 0, that means finding where it sits below or underneath the x-axis, right? Where the y value is negative, Well, where does it sit under the x-axis? So I'm going to check each of these intervals. If I take an x value in there, like -2, for example, and plug it into this function, are we going to get back a positive value or a negative value? Negative, because here's the graph, right? It's sitting in negative y territory. It's sitting under the x-axis. So that inequality is true here, right? Because it's sitting, again, underneath the x-axis. Okay, what about here? If I plug something in from that interval, we're going to get back something positive because it's sitting above. Well, the inequality, the question was, where is it less than 0? Where is it underneath the axis? Not here. What about here? Yeah.
Does the graph not ever bounce with the -5x squared?
No, because it's not that there's a square term in there somewhere. It's that if you factor it,
Okay.
you have a square factor. So like if I factored this thing all the way down, it would be x times x minus 1 times x minus, plus 1, sorry, times x minus 6. That would be the factored version of it. Because there are 3 zeros and the degree is 3, there's not room for any of those to be like repeated.
Okay, so it's based on the factor.
Yeah, right. Which we didn't find along the way to getting it, but since we have the 3 zeros, we can, sort of fill that in, right? Okay, this next interval. True. And then after that, false. Say again. No, it does not always alternate. Is that the question?
No.
Oh.
This is the weird ones you were talking about.
Oh, yes, right. Yeah, there are more pieces. That means there are more things we got to consider. That means there are more possibilities for what can happen. And yeah, again, we want to be careful about like thinking that it always alternates because it doesn't. What's the solution set then? It's the interval notation version of everywhere that we just decided the inequality was true. So everything from the beginning of time, right? So from -infinity up to -1. And then skip over some stuff. And then everything from 0 to 6. So again, we see the zeros, right? The intercepts show up as being the endpoints because that's where things change. And then we have those 2 intervals where the inequality is true. If I ask the reverse question, where is it greater than 0, it would be the other 2 intervals, right? To fit in around those. Okay, so nothing new really, except that we have a little bit more stuff to cover or to consider because we've got possibly more intercepts, more solutions. Okay, let's take a look at 8 real quick. X to the 4th minus x squared greater than 0. Okay, x to the 4th. So I'm expecting as many as 4 intercepts unless there's some multiplicity stuff going on, right? How do you want to solve this? There's a common factor of x squared. If we take it out, what's left? Okay. And x squared minus 1, that's a difference of squares. So we can factor that further, right? That would be x plus 1 times x minus 1. Or you can use the quadratic formula, be a 0, or you can, move the 1 over and take a square root or whatever. Like there are a bunch of ways to get there. But what are our solutions then? 0 and -1 and 1. So there were only 3, which means one of them has multiplicity 2, right? One of them's got a higher multiplicity. Which one is it? Because of this x squared term, that one's got multiplicity 2, right? That one repeats, that one counts twice. Why do we care? That's going to affect the graph, right? It's going to bounce off there instead of crossing. So when I go to graph the thing, and by the way, reminder that like you're allowed to graph in calculator, right? So like you can graph it, I'm graphing it kind of by hand. You can look at a graph in a calculator if you want to, be more sure about it or whatever. Ooh, 10%. Makes you feel really irresponsible as an adult when.
With corrections.
Yeah, yes. Yeah, right, yes, sorry, gotcha, yes, yeah. Okay, so x to the 4th. So what do the ends look like? Same direction, both up, right? Even degree, positive leading coefficient, both ends point up then. And then we've got intercepts at these 3 points. And the one at 0 is multiplicity 2, so it bounces off, right? Okay, well, to get from one end to the other, I got to start here. We cross here because there's an intercept, and it just showed up one time. Its factor showed up one time. It's got multiplicity 1, so it crosses and then bounces off and then crosses again. It has to be like that, right? It has to be like a W-shaped thing to get from where we started to where we're going and hit these points in between the way they're supposed to happen. So it's just this big W-shaped graph, and we're asking where is it greater than 0? So check the 4 intervals, right? Again, if you want to do that numerically, then plug in. If you want to do it from the graph, then do it from the graph. But if I gave x equals -2 and plugged it into that thing, the graph tells me that the y value I got back would be positive. Since it's positive, it's above or greater than 0, so that inequality is true here then. And here, false, and here, false, and here, true. Right, I want to take everything that's sitting above the x-axis again, you would get the same thing. It's going to probably take a bit more time maybe, but you have a calculator. If you want to plug in -2 and see what you get, then like do that. Plug in 1/2, see what you get, do that. That's fine. What's the solution set then? Negative infinity to -1.
In bracket.
1 to infinity. This was strictly greater than, right? Greater than 0. At the endpoints, they're equal. So parentheses on both ends. Because 1 in that inequality, like if I plugged 1 into the inequality, it would not be true, right? Because I would get 0 greater than 0, and that's not true. So parentheses on the endpoints. Yep, good. 5%. Whew. Okay. Is everybody okay with that? Yeah. No.
How do you get the, how can you tell if it's both going up or
So
that's negative?
the degree being even means they're both going to go the same direction. So even tells me that they're going to do the same thing. Since it's positive, that tells me it's going to go up. So just like for a quadratic, if the leading term is positive, then it opens up, right? It's the same idea. There's just maybe more stuff happening in the middle, but the ends are still going to do the same thing. So anytime the degree is even, they'll do the same thing. If it's odd, they'll do opposite things. But the leading sign, the leading coefficient is gonna tell you what the, what the sort of right end does. That one, what that end does, yeah. Okay. Anything else? Stop this.